Hello, ladies and gentlemen. We're going to be talking about lesson 77, absolute value inequalities. Hopefully you did go through and actually do what I asked you to do, which was 77A, just about absolute values in general. If you didn't bother watching that video, please go through, do those notes, and watch that video. Hopefully the sub is giving you the notes for absolute value inequalities lesson 77. If not, all notes can be found on OneNote, and all notes can be found on Teams along with this video. I will also send you an email with the link to the video and the notes attached. As we know, when we're talking absolute value, we're talking about distance away from zero. So the absolute value of 2 would be either -2 or +2 because that's the distance away. Once I mix inequalities into the mix, I now am looking at a situation where like the absolute value of x is less than 2, which means that I'm talking about that's 2 units or shorter, which means I would be somewhere between -2 and +2, including being 0 units away. Does everything inside there. You would check that by plugging numbers in. You would pick a number that's greater than -2, that'd be greater than 2, like a 3, between -2 and 2 is 0, and then less than -2, like a -3, and you can see where it works. If it's strictly greater than, we know we don't have an equal sign there either. Open circles, just like you saw here and here. Open circles here and here. This is the or statement. This is the and this is the or. All right, so we will have an option. You can either be smaller than -2 or greater than 2, but you cannot be both at the same time because it's an or. Less than or equal to, we now have the situation where we're including both 2 and -2 right here at the endpoints. They're solid dots. They are being included, so you could be -2 or 2 as the actual answer, whereas above, in less than or greater than, they could not be the answer. Greater than or equal to, again, same idea. Now we're just talking about the outsides here, and we're talking including the red dots as well at 2 and -2. All of this should sound relatively familiar, as this is technically all review of stuff you have done from Algebra 1, but we make sure we're on the same page. As we look at page 2 here, we're talking about our symbols and making sure that we are talking about them correctly and they're read correctly. If a is greater than 0, then the solution of the absolute value of x is greater than a, where a is greater than, where x is less than a and x is greater than -a. Also written in the form of -a less than x less than a. If a is less than 0, that means we have the absolute value of x is less than 0. Yeah, we have to make sure we're everything pointing the same direction. If it's greater than, then we have to make sure we're greater than. Here are the two cases. We have a situation here where we have x minus 3 inside the absolute value, and you have to split that case. So it's x minus 3 is going to be strictly greater than or less than or equal to 4, as the sign says, and then you flip it around. Negative x minus 3 is going to be less than or equal to -4. You're adding your 3, you're adding your 3, you're adding your 3, you're adding your 3. You can solve these simultaneously next to each other. I'm just doing it here. X is going to be less than or equal to 7, and x is going to be greater than or equal to -1. And that's where that's going to be, your numbers are going to fall between -1 and +7 inclusive. Why? Because of the equal sign. Once the equal sign is there, you're including both those endpoints. For example, number 2, you have the absolute value of x minus 20 is greater than 5. So in this case, you want to do x minus 20 is greater than 5, and x minus 20 is less than -5. You need to solve both of those simultaneously. Solving them simultaneously, you're going to add 20 to both sides. Again, you can solve them separately. I did them right on top of each other. It's not the end of the world. You're going to end up with x here, so it's 20 plus 20 here, plus 20 here. You're going to end up with, this is going to be x is greater than 25, or x is going to be less than 15. Oops, 15. Which you get right here at the bottom as well. Okay? Now, there's no such number that lives between that's greater than 25 and less than 15, so this is why this is the or. Okay? It's your conjunction and versus your disjunction or. You have to remember that situations can be that it lives on either side. We'll see more real-world examples of this when we start getting into word problems. As we look at the next page, we have a situation here where there's a number being subtracted on the outside. I can't deal with that until everything has been moved away from the absolute value. I need a clean absolute value before I can start trying to change signs. So I'm going to end up with the absolute value of 3 plus x. And I'm going to move that 4 over with addition is less than 4. So now I'm going to take both cases here. And the situation is 3 plus x, is less than 4, and 3 plus x is greater than negative 4. Solve both of them simultaneously by subtracting your 3, and you get a 1, then you subtract here, and you get a negative 7. Now, now you're going to start seeing, does this work? Are there numbers that live between 1 and negative 7? The answer is clearly yes. 0 lives there. You check that number. You plug in and check. Pick something bigger than 1, like a 2, something smaller than negative 7, like a negative 8, and pick something in the middle, like a 0, and you see where this works. Now, the problem is, and I shouldn't not say problem, is if you are just going quickly, keep track of your signs, especially your negatives, and making sure you're flipping your inequalities. If you don't take care of your signs and make sure you keep track of them, you will end up with answers that don't make any sense. Now, could the check save you at the end? Possibly, but at the end of the day, you need to make sure you're doing things correctly in the correct order the first time, so you're not wasting time redoing things over and over again for absolutely no reason. Example number 4 is what's called a complex, not as in imaginary, but complex inequality, because it has inequalities on both sides, and there are 2 different numbers to check. We have to make sure that our inequality is not only greater than 5, but is also less than 7. And that's going to lead to a situation where there is possible overlap. And we have to see, where do these things actually work? There are 4 distinct cases that need to be checked here. 4 cases. Why? There are 2 on the bottom and 2 on the top. You can treat this as if it's 2 separate inequality problems, where 5 is less than the absolute value of x plus 1, and the absolute value of x plus 1 is less than 7. You can treat them as 2 separate individual problems, and treating them as 2 separate individual problems might help some of us who are having a hard time doing all this at one time. 4 distinct cases must be checked. There are 2 separate problems. So we take the first one. I'm going to take the less than 5 is less than absolute value of x minus 1. You do that out. You actually solve each one of them out. You see, you end up with x is less than 4, or x is greater than 4, or x is less than negative 6. I put both those on the number line. Notice keeping open circles there because of no equals. And then I take x, the absolute value is x plus 1 is less than 7, treating x plus 1 less than 7 as its own, and then x plus 1 is greater than, why, that sign is incorrect. I'm sorry, that sign should have been flipped right here. This should be here. This should be x plus 1 is greater than negative 7. It's fixed on the next line. I'm sorry, it's not fixed on that line. You need to make sure that you're flipping your sign there, because once you change that to negative 7, you're flipping your sign. This will still solve out to be x is greater than negative 8. It did not change the answer, it's just the symbol is wrong, and I will fix that. You want to make sure, though, now you have that in the number line. So you've graphed a circle at negative 8, and you've got a circle at the positive 6. And when you're looking, it means that the solution, negative 8 is less than x is less than 6, as well as 4 is less than x and is less than x less than 6. The problem is the overlap is what you're looking for. You're looking for the overlap here and the overlap here. Why? Because the stuff in the middle, this stuff right here, this stuff on the outsides, it only works for one of them. It has to work in all 4 cases. So if I was to pick a number, let's say 0, and I plug 0 back in my original, it might work one way, but it won't work the other. Watch. 5 is less than the absolute value of 0 plus 1 is less than the absolute value of 7. 5 is not less than 1. That fails. So even though that works for less than 7, 5 is not going to be less than 1. So it has to fail. So the answers lie here and here in the overlap. And that's important. On to the next example. We see here a situation where as I solve this, I have the absolute value of something greater than a negative number. Well, anything's going to be, the absolute value is going to be greater than a negative number. I end up with every number that is not only greater than negative 7, but every number that is less than negative 1. So when I look at that overlap, the overlap actually is everything. Everything will work. So that's why it says all real numbers, right? You can also have a situation where you have the absolute value of something less than a negative, which we know will fail. There's no numbers that are going to work where x is less than 7 and at this end, x is going to be greater than 5. So that's going to give you the empty set. Now remember, the empty set can be written as the null set like it is here, or you can write the empty set with your curly brackets or empty, or with a 0 through a line through it, or just put, empty set, and that's what's going to happen. It's the idea though is that this is the top one is everybody, and the bottom one is nobody. All right, both of those can occur, and you have to be ready for that to occur when you're doing this. That is why it's very important to keep your signs straight. It's very important to make sure you track your inequalities and make sure you keep when you're plugging things in that is actually being plugged in correctly. All right, so it is reported that the average yearly salary of a computer programmer in the United States is $51,423 per year, but can vary upon location. The difference is an average of $15,559. It says write an equation to show this and then solve the inequality. Well, you can see right here, it's going to be the absolute value of x minus a is less than b. And that means it's the x, whatever they're making, minus the average salary of $51,423 has to be less than or equal to $15,559. Why? Because if the average salary is $51,423, you want to find the difference between their amount and the average amount. And once you find the difference between that amount, that number should fall somewhere in the absolute value of that below $15,559. And we see when we solve this out that the average salary could be as low as the low salary should be $35,864, with the high salary being $66,920. All right, we did that by solving each one out, finding numbers that work in the middle, make sure that it is an and statement because we want to be in between. All right, let's look at this example here. It says x plus 2 is greater than 5. X plus 2 is greater than 5. X plus 2 is less than negative 5. Minus, minus. Solving simultaneously. That comes out to be a 3. That comes out to be a negative 7. Okay? So I put that on a number line. Here's negative 7. Here's 3. These are open circles. Pick a number between negative 7 and 3. Yes, we're going to pick 0. Obviously, 0 is the right number to pick. 0 plus 2. Is that going to be greater than 5? The answer is no, so I don't want this. Pick a number bigger than 3. I pick 4. 4 plus 2. That's going to be 6. We're good. Yes. Pick a number smaller than negative 7. I'm going to pick negative 8. Plus 2. It's going to give me a 6 again. That's good. We shade outs. Shade our outs. And this is an or statement. How do I know? Because I want x's that are less than negative 7 or x's that are greater than 3. That's an or statement. You don't live in the middle, you live on the edges. Okay? Looking at the next example here, this one's set up already for us. It's saying I want a number that's going to be less than a negative. I know this is the empty set. I know it's going to be empty set. We can show it's the empty set, but I know it's the empty set. Why? Because I cannot have the absolute value of something be less than a negative. If this was greater than negative 12, not less than negative 12, it would be all real numbers because everything's going to be greater. This is clearly just the empty set. Now, if you look, you have a situation number 10. We'll go back to number 10. Number 11 is set up for us with a number on the outside to be moved. Number 10 has an x out there. You have to be very careful when you're moving your x. That is where the most mistakes occur. Because if I do this, it's 2x plus 3 greater than x plus 6, but it's also 2x plus 3, or excuse me, 2x plus 3 less than x plus 6, and then greater than negative x minus 6. I must negate everyone. So as I start moving pieces around, and I'm moving pieces around here, okay, subtract that x, subtract that 3, x is going to be greater than, x is going to be less than 3, but here 3x is going to be greater because this is a 3, excuse me. Let me erase that. This is a 3. And it's going to be minus 3. Sorry, ladies and gentlemen. Minus 3. You have 3x on this side. This cancels. This cancels. It's going to be negative 9. And x is going to be greater than negative 3. So we want to test this out. Okay? Now, this could work. This could fail. This could work in parts. I pick, here I am at negative 3. Here I'm at 3. There are open circles here and here. Give me a number between negative 3 and 3. That's right, we're picking 0. So 0 plus 3, is that smaller than 0 plus 6? Well, 3 is less than 6. That's true. So this works inside here. Pick something bigger than 3. Let's go 4. 2 times 4 is 8. 8 plus 3, is that going to be less than 9? And the because it's 3 plus 6, the answer is no. This fails. X out there. And we're going to pick something smaller than negative 3. How about negative 4? So negative 8 plus 3. Is that going to be smaller than negative 3 plus 3? And what you end up with here is going to be, this is going to be 5 when you're all done, and that is not going to be smaller than 0. So that X is here. So your shade's middle. So that middle shade, so for this guy, come here, is going to be negative 3 less than X, less than 3. Okay? Number 11 here, see if I have some room. Maybe I can move the page a little bit. Sorry. See if I can move this. There, I'll just move that like that. Who cares? Okay, here we want to go, it's 5 minus 4x. Now that plus 2 has got to move. That plus 2